Okay. Welcome to Redzone number 3. As you're looking at the screen, you probably think this red zone is going to be about rate of change and slope, but that's actually not true. This is just a warm-up question because slope, rate of change, has been coming up since 7th grade, all of 8th grade, and it will come up all of 9th grade and a lot of 11th grade, even 10th grade a little bit. So take a second, do this problem, pause it, do it, unpause it, I'll go over it. Okay, so it says which one has the least rate of change, meaning we need to find the rate of change for each of them. Rate of change is another word for slope. So to find the slope in the graph, there's two ways, well, three ways. One way is to do rise over run. You need to pick two coordinates, count how much it's going up, count how much it's going over, write it as a fraction, simplify it. The problem is you have to look at what they are counting on each axis. So the y-axis, every time you go up one box, it's really 100. And on the x-axis, every time you go over one box, it's really 5. So that's one way. Another way is you can pick 2 points. You can write down the coordinates of each point, and then you can do the slope formula. And the third way, and this only works sometimes, is if the graph is a direct variation, meaning it's proportional, meaning it starts at the origin, you can just look at any of the points and just put the y value over the x value, and it'll come out to the rate of change. This only works when the graph is proportional, a straight line that goes through the origin. So the rate of change for A is 20. The rate of change for B is 19. I know that because y equals mx plus b. The rate of change for C, there's two ways you can do this. One way is to do the slope formula. If you don't remember that, it's y2 minus y1 over x2 minus x1, or you can do the jumps. So you can see that it goes plus 1, plus 1, plus 1, and then it goes plus 3, plus 3, plus 3, and you put the y over the x, so the slope is 3. And the last one, the cost of the house cleaning service is $40 per hour. That's how you know that one is the slope. So C is the least rate of change, which brings us to Redzone number 3, which is all about exponents. So remember that, I'm going to use pen here, a random exponent just tells you how many times to multiply the base by itself. So for example, 5 to the third power, we call the 5 the base. We call the little number up here the exponent. The exponent tells you how many times to multiply the base by itself. This is called exponential form. This is called expanded form. And then when you get the answer, that's called standard form. 5 times 5 times 5 is 125. So that's your basic review of an exponent. Something that came up, anything to the 0 power is 1, not 0. Anything to the 0 power, I was just going to do the same exact example. A to the 0 is 1. X to the 0 power, even though we don't know what x is, it's still 1. So that was that. And then after that, we learned about negative exponents. So for example, 8 to the negative second power. Well, we don't really like negative exponents, but there is a way to make them positive. So to make it positive, first, you flip this upside down. You do the reciprocal. The reciprocal of 8 is 1 over 8, and you change the negative exponent to a positive exponent. So now it's 1 over 8 to the second power, which is 1 over 64, nice and easy. So that's how you deal with negative exponents. That's pretty much it. Then we got into lesson 2 of that unit, and it was the laws of exponents. So the first one we learned was the product rule. Product meaning multiplication. When you multiply two terms together that have the same base and have exponents, we learned that you keep the base and you add the exponents. So you keep the 4, and then you do 3 plus 5, and that's where the 8 comes from. So that works when it's variables too. So x to the 5th power times x to the 10th power equals x to the 15th power, because 5 plus 10 is 15. So that's the product rule. Then we learned the opposite of that, called the quotient rule. The quotient rule is when we're dealing with division. So for example, 6 to the 8th power divided by 6 to the 5th power. And this time you keep the base and you subtract the exponents. So 8 minus 5 is 3. The problem that came up with the quotient rule was when we had to deal with negative exponents. You don't have to fix them and turn them into positives until you're done. But the problem is, in 7th grade, we learned how to add and subtract negative numbers, and that concept still is a little shaky with a lot of us. So for example, 4 to the 3rd power divided by 4 to the negative 4th power. A lot of you will look at this and write the answer as 4 to the negative 1st, but this is actually 4 to the 7th power, because 3 minus negative 4 equals 7. So be very careful with your positives and negatives. Use your calculator to help you. Then we learned the third law, which is called the power rule, or the power to a power rule. It's when you take something that already has an exponent and you raise it to another exponent. When you do that, you keep the base and you multiply the exponents, and you get 4 to the 15th power. All right, so let's practice these rules. Here's your first question. 5 to the negative 8th power times 5 to the 4th power. So again, pause this, try it, use your calculator. You can use your calculator for this, but you don't need to, and then unpause it. All right, so I noticed that we are multiplying, and both of these terms have a base of 5, so I can apply the rule, keep the base, add the exponents. Negative 8 plus 4 is negative 4. So 5 to the negative 4th power, but that's not a choice. But to fix this and rewrite it with a positive exponent, you take the reciprocal, and the negative exponent becomes positive. So that's choice A. I did mention that you can do this in your calculator. What I meant was that you can take this, the original question, type that into your calculator, so 5 to the negative 8th times 5 to the 4th power, hit enter, and you get 0.0016, which is obviously not a choice, but then you can just type in each one of these choices until it gives you the same answer, and then you know you have the right answer. All right, so this is an old state exam question. This is a great question. It's not super easy, but it's very doable. If you guys remember the exponents and remember the rules, this is a huge topic for any math class you're going to take moving forward, except maybe geometry. So let's read it out loud, and then you're going to pause it and try it on your own. Jude incorrectly simplified the expression 1/2 to the 2nd power times 1/2 times 1/2 to the 3rd power, as shown below. And you can see that he did equals 1/8 to the 6th power, and that equals 1 over 262,144. Describe the mistake that Jude made. Write your answer on those lines, and then below, correctly simplify it. So at this point, pause the video and really try it. Even if it doesn't come to you right away, try to figure it out. Use your calculator to help you. See if you can write a good explanation. Take 5 minutes. Give this a go. Look up the rules again. Don't just give up. Now's your chance to really persevere through this. And when you unpause it in about 5 seconds, I'm going to start going over the problem. All right, so the first thing that I'm looking at is, well, it doesn't look like you made a mistake. And that's my first instinct sometimes, because it looks right. 1/2 times 1/2 times 1/2 is 1/8. But if I take this part and I type that into my calculator, being very careful with my parentheses, with my fraction button, with my exponent button, if I enter that into my calculator, if you want to do that now, pause it and do it. and I entered incorrectly and I hit enter, this actually gives me the answer of 1 over 64. Well, that is clearly not what Jude got. So Jude did make a mistake, which they told us. I can't tell you how many students, when I was grading this question on the state exam, graded this question hundreds and thousands of times, wrote, Jude did not make a mistake. He did make a mistake. The question is telling you that. So you have to find the mistake. Some kids did write, he made a mistake because the answer is 1 over 64. That will not earn you credit. You have to describe the mistake he made. And if you remember, we just went over the product rule. Product rule, because this is multiplication. Jude, here we go. Jude did not keep the base the same. When you multiply, you keep the base and add the exponents. Jude multiplied the base. 1/2 times 1/2 times 1/2 is 1/8. But when you are dealing with exponents, which we are in this question, you have to keep the base the same. So that was Jude's mistake. Now we need to simplify this question. So you can see right here at the bottom, we need to simplify it. Now that we identified the mistake, even if you weren't able to do it on your own, pause the video again and see if you can do it correctly this time. If not, I'm going to go over it now. So we just talked about how you have to keep the base the same and add the exponents. So it's going to be 1/2. So I have to add the exponents. And here's another mistake a lot of students made. They did 2 plus 3 and they got 5. 2 from this one, 3 from this one. But what about this one in the middle? You can't ignore it. It's there. Remember, if something doesn't have an exponent, there actually is an imaginary exponent there. It's a 1. If I was going to expand this, 1/2 squared would be 1/2 times 1/2. Then times the 1/2 that's in the middle, and then times 1/2 to the 3rd power, which would be 3 of them. How many do I have? 1, 2, 3, 4, 5, 6 of them. So 1/2 to the 6th power. And if I want to turn that into standard form, 1 over 64. All right, try these 2 on your own. When you unpause the video in about 5-6 seconds, the answers are going to be up, and I'm just going to do a brief explanation. Okay, you can see in the first one, the first thing I chose to do was simplify the right side of the equation. That's the power rule. When you have something with an exponent and you raise it to another exponent, you keep the base and you multiply the exponents, you get 2 to the 12th. And on this left side, I noticed that they're being multiplied together, so this would be the product rule. So you have to add the exponents. So 2, and if you look over here, 2 plus n equals 12. This is all the exponents. 2 plus n equals 12. So the missing exponent has to be a 10. Then in the bottom question, if you look, the first thing I did was put an exponent of a 1 on that 2, because a lot of students forget about that. Then I used the quotient rule right here, and I divided, so I subtracted the exponents, and I got -3. And then I used the product rule, so I added the exponents, so I got -1. Okay, so for each one, you have to draw a line from each expression to its equivalent one. So pause the video, unpause it when you're done, and we'll go over the answers. Okay, so the first one, 9 to the 3rd power to the 6th power, you keep the base, you multiply the exponents. 3 times 6 is 18. So you can see that this matches up with that one. I look at the second one, and in the parentheses, it says 9 times 3 to the 6th power. Well, I could simplify that in parentheses, so that can actually be 27 to the 6th power, because 9 times 3 is 27. And I look at the choices, and choice A, this first one, definitely is not it. The second one also is definitely not it, so it must match up with this one here. We didn't learn that rule because it doesn't come up much, but that is a rule. Yeah, this one's also 27 to the 6th power. And I look at the third one, same thing. I notice that I can simplify what's inside the parentheses. 9 divided by 3 is 3. So it's 3 to the 6th power, which matches up with this one. And then this last one, I used a quotient rule, keep the base, subtract the exponents, and I get the first one. And that's it. That's all we have to do for exponents, because that's usually what comes up. So hopefully this helped. Hopefully, if you are not understanding anything, you are reaching out to your teachers. Please reach out. We are sitting around, ready to go live, ready to help you, ready to answer your questions. Stay safe. I said safe. Stay safe. Stay healthy. Stay active. Have a good day.